you, and I'll send to you.
Wow.
Every day, daily crunch Sunday. Every Sunday, daily Easter. Higher than me, higher sister. When charge too much, what you mango do? With the whole on a tutu. Got it too much, but a few. But yo, the kid on a tutu. There's a fat girl, some fat show. Small waist,
Alright, DJ, you know the drill. I'll send you the link to the.
Oh, I don't even have Facebook on my phone.
Okay, that's fine.
So I don't know.
Should I
I
send
don't know
you
how I'm gonna
YouTube?
share it. I don't know how I'm gonna share it.
Should I send you
You now have
YouTube?
to pay. What, YouTube?
Yeah.
What am I gonna do with YouTube?
But that's fine. You can share it later.
Yeah, I will just have to share it later because I don't have social media on this phone.
Yeah, I'm afraid that you put it there to distract the hell out of you.
Yeah. Social
Mashallah.
media is
Wait,
crazy
man.
these days.
Hey guys, it's been a while. Today we'll be chatting with DJ Perez. I mean, we've been hustling in the back room. Guys have been hustling, stashing stats. What did they say? Stashing stats. Hey DJ, you know.
Wait, is it bread or cheese? How do they call it these days?
No, those in the Bitcoin space. Since one Bitcoin is split into like 100 million satoshis, so we're busy buying satoshis. So they say you're stashing or you're stacking stats or sats. Yeah.
Yeah, I see.
Yeah. Mashallah. So DJ, welcome.
Have you stashed a lot? Oh, thank you. It's nice to be back here. It's been a very long time, man.
I'm stashing enough, and I'm still stashing. So every day,
I trust
man.
you for that.
Even today, like every day, I stash. Like as the price goes up and down, I just buy like $100, $150, $200, $500. That's what I want. Like depending on the price. And then when it goes down, I'm like, what? I put like 3K. You see what I mean?
Yeah, you just put everything in it.
Yeah.
Not everything, but you maximize your gain from it, I guess.
Yeah, it's a game. Yeah, you know, like it's a savings account now, so I have some kind of allocation, the budget I've allocated to it. So each time, just send a little to it, and I need to do that for a couple of years because imagine the dudes that started stashing like in 2010. Now they're looking, they have a couple 100 million. They're like, hey.
I know.
Hey. Can you
I
imagine?
know, man.
Yeah.
So what are we going to talk about? Are we going to talk about the consensus? Are we going to talk about Acoin? Are we going to talk about what are we talking about?
You drive it. Like I think we should start with consensus and things like that. So we drive on understanding, and that sets a stage for every other thing that comes on top of it.
Yeah, like my first question that I had for you today, you remember, is I really want to understand this consensus.
Yeah.
So in terms of consensus in the financial world, first of all.
Yeah.
And then what are the different algorithms in the crypto space that they have to implement consensus? And then also we can drill down further because recently I heard about Ethereum and proof of stake, proof of, what was the other one? Proof of work and proof of stake. So I'm trying to understand all of these. So you're the crypto man. Please explain that to me. And I'm sure you're going to explain in layman's terms so I will understand.
I mean, I'm a learner. All of us, I'm a learner. So I'm not like a man. But anyway, DJ, I mean, for a start, consensus is some sort of agreement, right? So, and mostly in the crypto space, you hear things like protocols. Those are just normal words for like algorithms or techniques. So if we agree now that we want to use bubble sort or quick sort for us to sort in a certain language like C, then that's our consensus. So consensus is that agreement that everyone has on a certain topic. You see, so just like in democracy now, when people go vote, all we're trying to do is come to consensus that like Joe Biden is the president of America. So all of us do that with the votes, and then they count it, and the emergent thing, the results is like our consensus. You see, as opposed to maybe some minister just being appointed by president, and then we kind of receive that like gospel. You see what I mean? Yeah. So for a start, that's what consensus is. It's like agreement. Yeah.
Mm-hmm. Oh, this guy.
Yeah, DJ. So that's that for consensus. So I don't know if yeah.
No, that it sets the stage properly. I understand
Yeah.
the consensus part in the I guess that's a kind of the lexicology, or that's how you call it, but the meaning behind the word, yeah. Now in the crypto, or well, now in the financial space, how do you apply consensus?
Yeah, so mostly consensus is a word that I got in the crypto space. So, and let me know if
Mm-hmm.
like my background, if you get like noise on me, let me know if that's enough.
Okay, I will. Yeah.
Okay, yeah. So in the crypto space, right, it's a decentralized
Mm-hmm.
network. So there's no central server telling you the truth of things. If that's the case,
Yes.
then how do we agree that this transaction that DJ sent to me is valid? So
Mm-hmm.
since it's decentralized, every Bitcoin node or in other cryptocurrencies, every node has to make sure that transactions coming in are valid. Like maybe they
Mm-hmm.
have the correct signatures, cryptographic signatures, they have the correct inputs, because the transaction is like a function that receives input and returns output, right?
Yeah.
So they all have rules, just like how the compiler is going to check whether you passed in an integer instead of a string, right?
Mm-hmm.
Yeah, against the signature of a function. So in a decentralized network, there is one ledger that has the truth of everything. So everyone in the network has to sync to get that network, and sorry, to get
Yeah.
that ledger. So the time when everybody has the same ledger, it means all of us have agreed that this is the current state of the system or the network. So that's consensus.
Correct.
Yeah. So now every other thing will just be the mechanism by which the network comes to consensus. So that's where you could use proof of stake or proof of work.
So I guess the final output of the consensus will be that every node on the network has to have the same ledger.
Yes, when all of them have it, it
Okay.
means we're in consensus. Because so for in Bitcoin, for example, it takes 10 minutes on average to come to consensus. So
Yes.
yeah, so as I send you Bitcoin, everyone is sending Bitcoin. It takes those individual transactions and packs them into a batch, right?
Yes.
Just like how they make passports. You go to Boya, and after a certain number, they send
Yeah.
to Yaoundé. So
Correct.
now, that when that batch of transaction is there, a miner now will take it, because the Bitcoin blockchain is free. Everyone can jump in and out. So
Mm-hmm.
so now, because of that, anyone, there's a competition now for the one person that will like update it. So the miners compete based on like machine power. So you who can perform faster computations, you now have to look for a certain number in nonce. You have to like look for the hash of that nonce
Yeah.
up to
Yeah.
a certain
Yeah.
error. So the first person to get it broadcast to everybody, and it's this system where it's easy to verify it. It's easy to verify a hash, but it's hard to hash something. You see what I mean?
Yes.
So
Yes.
now the miners have to look for that hash manually by trying, is it one? No. Is it the hash of one? No. Is it the hash of two? No. Is it the hash of 0. This? No. So by the time they are within a certain error margin, they are correct, because what it does is it says find this hash that starts with 00, like maybe 1,000 zeros. So you have to do
Mm-hmm.
thousands of hashes for you to get to that number. So the first person to get it will now take that hash and broadcast all the transactions in the batch and the hash, and that hash now will be the key that says, okay, this is correct. So everybody can just validate it, and when it takes O of
Mm,
one. So if it works, you know that that miner did the right job, and then you add
yeah.
it to your ledger in this decentralized network. Every other person takes it, verifies it. If it's correct, they add it. That's it.
So you're saying that the one node verifies the transaction and publishes it
No,
to
one
well
node solves it. So think of it like a
well no
puzzle.
sorry okay, I see, I see. So one node solves the
Yeah.
transaction, and then once it's solved, you publish it now to all other nodes
Yeah.
with the output of your calculation.
Yes. So it's like the World Cup.
Oh, okay.
People are
So
challenging, right? People are challenging like World Cup. There's this challenge for someone
yeah.
to take the cup. So the
Yes.
first person to win it will say, okay, for this batch of transactions, this is the solution to the puzzle. So I will take the solution, my node. I have 2 Bitcoin nodes here at home. My node will take it and then check. If it's correct, then I'll update my ledger with the latest block of transactions. Every other person in the network will also take it and update it. And then when all of us have that same transaction, the batch added, then we're in consensus. That's when agreement that this is the current state of the Bitcoin blockchain. So you see how, yeah, so that problem, it was a problem because it was, before that, it was hard to solve consensus on a decentralized network. Most, see, like Google, their servers are distributed across the world in Australia, America, Europe, but it's just one person that's controlling all. So they don't have difficulty updating all the servers because that one person just distributes it. But if you have a network of a decentralized network, you don't know each person. You don't even need to trust each person. Some could be trying to steal the money. So how do you make sure that a network where people don't need to trust each other can actually trust each other? That's the problem Bitcoin solves.
Yeah, so this actually explains already the proof of work, because in order for you to get the result, to get that number and to calculate that,
yeah,
you need to have very powerful machines.
Yes.
So your work, so that's proof of work.
Yeah.
Okay, that makes sense.
And it adjusts itself. If for example, you solve it in 5 minutes, the next time you solve it in 4 minutes, 6 minutes, it's gonna adjust. There's a difficulty adjustment. It's like if you're solving like a Sudoku and it gives you a 4x4 and you solve it in 1 minute, you say, okay, you think you're wise.
That is
nice. 16 by 16, you'll be like, what?
So this then explains how miners actually make money.
Yes.
Because I guess you get now the transaction fee from the processing that you just did. You will get the transaction fee from it.
And a reward, a block reward. So now that's how new Bitcoin are made. So when you mine it, it gives you the first transaction you add. The miner is allowed to add the transaction to it. So in the year when Bitcoin started, like 2009, 2011, that period, it was 50 Bitcoin. So after 4 years, it halves. So you see the math, you see that the first 4 years, 50% of Bitcoin will be released. Then the next 4 years, 25%. Next 4 years, 12.5%. Next 4 years, 6.25. So that's how, and that's how Bitcoin too is reduced. So it's deflationary. So instead of being inflationary, where the money is like increasing, the total supply, supply is the circulating supply is actually increasing, but at the decreasing rate.
Yeah.
So that's why Bitcoin keeps going up, because every 4 years when the supply halves, you see that the demand is this. If the demand is the same and the supply halves, then it means and the price should go at least times
the value
2.
goes up.
Yes, the value should go up because if the supply halves, then demand is already times 2 by default. You see, so then imagine incoming. That's why you see Bitcoin is used to just waking up and going to 100, like 64K, and people are like, "Is this thing mad?"
Yeah, I see. So then now that we are, well, I understand proof of work conception. I mean the concept. So how about proof of stake now? So how do they implement it? And also, well, first of all, why? Well, let's just explain proof of stake first, but I also want to understand the rationale, so the reason why they decide to change the consensus algorithm. So I don't think Bitcoin has changed. I think it's mostly
Bitcoin
Ethereum,
cannot change. Bitcoin will not change because
I think it's Ethereum.
Yeah,
I think it's Ethereum that changed. I read it recently about changed to
they are changing to proof of stake, but there are other networks that started with proof of stake like Tezos, Cosmos, Algorand. So with proof of stake now, because the idea, like we said, the fundamental idea is that we want to vote, we want to update a ledger, but all of us cannot update it at the same time. So it will be like, let's vote But that would be democracy. It means that look at how things are happening. There are people that they may not understand the system, and then a politician with a smooth tongue will talk to them, and
Mm-hmm.
then they vote. They eat sardine and vote. So then
Yeah.
proof of work is like proof of work is like, okay, you have to do the work. So if you can prove that you
Mm-hmm.
have worked for this result, then we'll know that this is correct, right?
Mm-hmm.
So now, proof of stake now says, okay, the person with the highest, or the person with a substantial amount of money. So proof of work is like the rich man can update it. You see, so that's why
Yep.
most people
Yeah.
don't like proof of stake, because
They
you
can
have to
abuse the
prove,
system.
yes, because you have to prove that you have a huge amount of stake in the system to update it. So, but there, because the main thing behind it is the incentive for you to secure the network. So they're saying that with proof of work, if you cheat, you lose. So if you try to update the system and you succeed, you earn Bitcoin. But if you try to cheat, right? So if you try to secure the
Uh-huh.
network, you succeed, you earn Bitcoin. If you try to cheat, you lose that electricity because it takes a lot of energy for you to compute the hashes. So you are not
Uh-huh.
incentivized to cheat. You can just use that time to secure the network. So proof of
Uh-huh.
stake guys are also saying if you have a high stake, you want to protect the network. So you are not incentivized to cheat because you lose the stake that you have. And if you try to cheat, the stake that you put is like a bond. The stake that you put in order for you to secure the network, if you cheat, they'll subtract it like a penalty. You see.
No, I don't see.
So
So,
if you put
what is
10,000,
the stake? What do
it
you mean by stake here?
the
Then
stake is a
you
coin.
just go.
Is a coin.
Uh,
So if you have Ethereum, for you to be now like a
mm-hmm.
stakeholder, you could say, okay,
Mm-hmm.
you can stake like 100 Ethereum, and that will give you
Yes.
a spot in amongst those who can update the ledger with latest transactions. So when the new
Mm-hmm.
batch comes in, the system runs a lottery, right? Each person can have a number, and then if the number falls on you, right, based on your stake and your probability is on par with your
Yes,
stake.
stake.
Yeah, so if you have like
Okay.
50%, then we can be sure that you have like 50% chance to win in one round.
Mm-hmm.
Yeah, so now the systems also have like validators. So when
Mm-hmm.
you so it will select some systems like Tezos and the rest, they will select like n numbers of validators. So if it picks me as a stake, it could have backup people so that if I'm not around or I'm not able to do that within the number of time that I've been allocated, is to go to the
Uh-huh.
next person like a fallback, right? And then once
Mm.
now you add those transactions, the validators will sign to make sure that okay, they have checked it, and if it's correct, they sign. So when those
Yeah.
validators sign now, then that's a new state of a blockchain. So it's almost like government now, where the rich man, you choose the rich people to update it.
So it changes things fundamentally. So what that means is, if I'm just a normal person, I want to start mining, let's say Ethereum.
Yeah.
Um, so we need to buy some Ethereum at the start
Yes.
in order to do that,
Yes.
to prove that I have some stake in Ethereum or I
Yeah.
believe in the system. So I
Yeah.
want to be part of the
Yeah.
mining community.
Yeah.
But then with proof of work, I could just have a bunch of money today and decide, okay, I just want to buy the machines, the biggest machines possible
Yeah.
to start mining Bitcoin.
Yeah.
What do you think is best?
I think it's proof of work. And the thing is that first of all, proof of stake, those that came up with proof of stake, they say that it's because Bitcoin consumes a lot of energy. They claim that it's wasted and the rest, but that's, to me, that's not a valid argument, because
Mm-hmm.
if you look at the energy is expended to secure the network, and now the Bitcoin blockchain has a market cap of like 900 and something billion. So
Uh-huh.
so that energy is expended to protect that value and the network, so it's not wasted. And then
Mm-hmm.
yeah, so those that start by saying proof of work is wasteful, they are having the presupposition that, how do they call that thing? They have a uh, uh, is it presupposition? What is that English word? Like when you have some kind of stand ahead of time, right?
What,
So,
predisposed?
yeah,
When you're
yeah, they have a
predisposed?
predisposition that what the network is doing is useless. So because if you're saying it's waste, it means that you don't regard what the network is trying to protect, right?
But I don't think they are looking at it like that though. I think they're only looking at how much power you will spend as a community or as a network
Yes.
to run the operations.
Yeah.
Because from what you explained, you will need complex calculations in order to whether hash the nonce or whatever to find the
Yeah.
to resolve the problem and update the ledger.
Yeah.
Yeah.
Yeah. Right.
So, well, first of all, I think there's one piece I need to understand. So, with piece of work, is it still the same where you have that nonce and then you resolve and then you get the hash and then you publish it to the whole network? Is it still the same?
They have a nonce, but there are different algorithms. They use like they could just use like SHA-256, right, or some hashing
Yeah.
function, and so they have like some simple stuff because the trust is now in the stakeholder, whereas in the Bitcoin network, the trust is in the process. That process of executing those commands to arrive at that nonce. You see what I mean? Yeah.
Yeah.
So since Bitcoin tries to create trust out of parties that don't need to trust each other, proof of work is what actually drives us to consensus. So, but for proof of stake, we're saying that we agree that those that have this stake, they are going to do the right job. So
So
you
the
can
assumption,
eliminate
the
that.
assumption
Yes.
and the risk here is that, I mean, the risk in the assumption is that people who have that stake
They will act
believe
correctly.
in the system. Yeah,
Yeah.
yeah.
So now,
Believe in the system.
yeah.
Yeah.
So now, with that, and then the proof of stake systems now, they also have the idea of delegation. So you now can have your coins, and then you can come and delegate them to me, and then I can use those coins now to show that it's a stake. So let's say if I'm a company, a crypto company, running an Ethereum node, and let's say I provide a wallet. So you can come and stake your Ethereum to me. That's you're giving me rights to use those, but you can pull them out at any time. So you can stake it to me, and then I'll take that pool and use as a stake. So that will show that okay, I'm bringing all these people. It's like a senator or like a parliamentarian.
Yeah.
Those people in the
Yeah.
village have told you that this is what we want. You represent them. Yeah.
I see. I see. So in proof of stake, there's still one thing that I don't understand.
Yeah.
I don't understand how you spend more, like you spend less power with proof of stake.
Yeah,
How do you
because
spend less power?
they don't have that hashing, that iterative brute force hashing process, right? So once I have the chance to add a block, it's a few seconds,
Yeah.
right? It's a few
Yeah,
seconds.
yeah.
I take it, I check the transactions if they're all right. The nonce mostly is not there for me to try to get a magic puzzle solution. Once those are correct, I just like hash everything, add it to the blockchain, and then or add it like to some pool, and then the validators take it, make sure that it's correct. So it's like just adding some cryptographic function, signing, and then pushing it to the next person in the pipeline. They check to make sure that the transactions are correct. I did not do anything wrong. They sign that this is correct. Like 5 of them or n of them sign, and then we're in consensus because those representatives have done their job.
Yeah. I see. And yeah, I understand the key thing about it now.
Yeah.
You made it very, very clear, by the way.
Mashallah.
Yeah. Yeah, you made it very clear. So how now? Let's jump to Acoin. So how is Acoin resolving consensus? I haven't read anything. I don't know anything. I just saw the news.
I
don't know anything about
think
it.
it's a proof of stake because Acoin is actually built on top of another blockchain called Stellar Lumens.
Oh, is
Yeah.
it? Is it
Yeah.
the one with the? That's the one with IBM that
Yes, that's the
you
one with
mentioned to me one
IBM.
day. Yeah.
Yes, yes.
Yeah,
So
yeah, 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 yeah. I
yeah.
remember. Yeah.
So Stellar Lumens actually,
Mm-hmm.
yeah, I think they use proof of stake, and
Yeah.
um, they give you a system that you can build on top. They have an SDK that you can use. They
Yeah.
give you simple objects like accounts and other cryptographic or financial data structures that you can use to
Yeah.
build on top of. So Acoin is
Yeah.
built on top of that. Yeah.
Yeah. I read that one day. They gave you. I think actually you sent me a link about Stellar
Yeah.
Lumens. So I had a quick look at it.
Yeah.
So with the Acoin on Stellar Lumens, now there's one thing I've always wanted to understand. Does that mean so Stellar Lumens is managed by IBM? Yeah.
No.
So
So Stellar Lumens is managed by the Stellar Lumen Foundation.
yeah.
Right,
So
they have a
what does
foundation.
IBM do with
So
Stellar Lumens?
IBM just used Stellar Lumens to build a trail. They want to build like a universal network for money. But that's built so almost
Oh,
like Acoin. So Acoin, they're using it to do their own thing. IBM used it to
yeah.
do their own thing. So it's like
I
how people
see.
use Node.js, and somebody will build like Google Maps. Some other
Yeah.
person can
Yeah.
build some other thing on it and stuff. Yeah.
Is it open source?
Yes.
I guess it
Yes.
is. Yeah.
Yes, it
Yeah.
is.
It
Yeah.
should be. Yeah.
So
So
it's
that. So
interesting. Yeah,
yeah.
all these things are interesting, and the foundation, like main invention that Satoshi and Nakamoto, the guy who did Bitcoin, brought in, is
Mm-hmm.
solving that consensus problem. It came from a problem that was specified, I think, in 1981 or 82 by Leslie
Yeah.
Lamport. Leslie Lamport did
Mm-hmm.
like distributed systems, so it was called the Byzantine general problem. So that problem is that how can people who are in a network that they don't need to trust each other come to agreement? So they call it the Byzantine generals problem because he was saying, imagine there are generals who want to attack a city, right?
Mm-hmm.
And then but the generals don't know which general is a spy. So, but you need to
Mm-hmm.
send information. We need to attack at the same time. So how can we come to consensus on the time to attack, provided that any of the generals can be a traitor? So we can send the message that let's attack at 1, right? And then
Mm-hmm.
the spy will go and tell those other people, or change the message and disrupt it and tell the other people, so at the end of it, we will not know when to attack. This is just set confusion. And then, in terms of distributed systems, think of a plane. It could be a system performing surgery. So the
Mm-hmm.
summary is that how can you make sure that the system that that has the possibility to send mismatched signals, how can you make sure that you do what it has to do? Like, or
Yeah.
how can you make sure a system that is failing or that is predisposed to fail, if possible, can actually work? So if it's an airplane, what if somebody hacks the plane and then the tires are supposed to come out, the wings are supposed to do what they're to do? What if they start sending mismatched signals? How do you still land that
Mm-hmm.
plane? So that's the Byzantine general problem. They don't need to, they are decentralized from different modules, right?
Yeah.
How do you make sure that they all do what they have to do? So that's the Byzantine's problem, general's problem. So Satoshi now took different solutions. Uh, proof of work was actually introduced by this guy called Adam Back, and he had done it
Mm-hmm.
for email to stop email spam. Because email, like back in the day, now email is decentralized. You just implement those protocols, and you can start sending emails to your computer. So people
Correct.
start
Yeah.
spamming mailing lists, sending all kinds of mails. I mean, Nigerian prince kind of a thing. So,
Yeah.
what Adam Back added is that in the headers, what if we allow you sending an email to perform a hash, and perform like hash some value and attach it to the head? So the person receiving it will have to validate to make sure that that hash is correct.
That. Yeah.
So
Yeah.
even
Yeah.
if you spend like, in terms of money, like 5 cents for one hash, if you have to send 1,000,000, you start seeing that money starts becoming more and more. So now people will not be able to spend emails unlimited, or send unlimited
Yes.
emails. Yeah. So that's how Adam Bash through what he called hash cash. That's how proof of work came. Then some guy called Hal Finney had taken proof of work and generalized it, making a way that you can reuse it in many ways. So Satoshi now, people are trying to create electronic money, but the problem they could not solve was the double spend problem. How can I make sure that I don't spend it twice? You see, so that's part of cheating.
Yes.
So Satoshi took all the solutions and made consensus using proof of work in that decentralized network to avoid double spending, and that's how Bitcoin came. So that's the core of it. Like that they call it
that explains the concept behind all these things and the consensus in crypto. Yeah.
Yeah, and then if you centralize,
you made it very clear. You made it very clear to me now. I can actually explain it to someone now.
And if you centralize, it's a single point of attack. They're attacking banks. They're hacking banks every day.
Yeah,
they're hacking banks every day, and they take everybody's money or email or private information. So if you decentralize it, you need to jump into everybody's computer and hack it to change the record or to do whatever you need to do. So if it's decentralized, it's exponential.
I guess there are some mechanism in each node to make sure that if you receive a node today and there is a mismatch, I'm sure there will be some kind of a mismatch detection when you receive a node or whatever. I'm sure. Is there any kind of mismatch detection or fraud detection for each node on the blockchain?
No, but because all of us agree just on the specification of the transactions, right? You know that, for example, for each transaction, a transaction is like a function. If you're doing Redux, the whole blockchain is the state. And then the transaction is a function, an action that takes input and returns output, right?
Yes.
So the sum of the input have to be greater than the output. And the difference is the transaction fee. You see what I mean?
Well, the sum of the output has to be
the sum of the input
greater.
The sum of the input has to be greater than the sum of
what
the
is
output.
the input here? What is the input here?
So now the input is Bitcoin that you want to spend. If I want to pay you,
then the output will have to be slower because you consider transaction fee or what?
Yeah, so the output now, for example, if I have 10 Bitcoin, I want to send you 5 Bitcoin. If I have 10 Bitcoin, because there's something called unspent transactions on Bitcoin, and Bitcoin does not have the idea of accounts. Everything is transactions. So if I send you 5 Bitcoin, you now have, if those are your first Bitcoin, you now have like an unspent transaction set, right? Made of 5 Bitcoin. You see, so that's your UTXO, unspent transaction output. So now, for you to spend that Bitcoin, if you have to send someone 6 Bitcoin, it wouldn't work because your UTXO, the inputs that you have, will be less than the 6 Bitcoin that you have to send. So that will not work. In the network, it's not going to work. You see what I mean? So if your unspent transactions are unspent transactions are 5 Bitcoin, you want to send me 6 Bitcoin. So your wallet will go to your unspent transaction set, pull all of them, it will have 5, and then it wants to send 6. So the input is less than the output. So that fails there automatically. Yeah. So even if you have to send 5, it may not still work because there's no transaction fee there. It may go, but it will not work actually. It has to be greater than.
Hey, I've always wondered about one thing. Does the network use HTTP or is it on a different protocol?
It's most of the things, right? You could do on HTTPS because it uses OpenSSL mostly for cryptography and things.
Okay.
But it doesn't matter because the way Bitcoin works, with my private keys, I'm the only one that can approve my unspent transactions. So if you send me Bitcoin, you are putting a hash of my public key there. So now what the wallet will do is the wallet will make sure that I, who has the private key, can prove that I'm the one who has that public key or the address that the Bitcoin is coming to. So
to
that's
own the
simple. Yes,
transaction.
that's
Okay.
simple because you just need to be able to derive that from my private key. But that's simple. It's all of one, probably to check it, right?
Yeah.
So now, once that's done, I can unlock. I can unlock it, right? So you who does not have that private key, you cannot do that transaction. You see what I mean? So that's the security. So that's the security that is added by cryptography. And that's what adds the trust to the system. So instead of having a middleman to do the verification and those things, the cryptography through verification and signing is what secures
And
the
that's that
network.
already. Yeah.
Yeah.
The security baked in, man.
Yeah.
Security is baked into the system.
Yeah.
This is cool. This
Because
is
I
cool.
could I could give you a Bitcoin transaction by I could send you Bitcoin by writing it down on a piece of paper and mailing it to you. And then once you input it in the system, so long as it gets to the blockchain and the miner adds it to the block, then the network will use the consensus rules. One of them was what I told you: input has to be greater than output.
Output.
Yeah. And then the other one is the address that you're paying to. You need a signature, right?
So this now brings me back to the lightning that you explained.
Yeah.
So if we're in this lightning, yeah, and so who does the consensus in this case now?
So now for
Is
Lightning,
it
right?
just okay? Yeah, yeah.
So for Lightning, you and I, we open a channel, right?
Yes.
And that
Yeah.
channel is like a multi-sig account, so you and I can sign it. But the way we open it is that when I open the channel with 1 Bitcoin, I pay 1 Bitcoin to that channel. You to pay what you have to pay. So, but I would sign a transaction that allows me to add 1 Bitcoin to that channel. You too will sign a transaction that returns 1 Bitcoin from that channel to me. Right? So once two of us now have that agreement, I accept it. Then I also sign a transaction that returns your own part of the Bitcoin. So that if we open that channel and then we don't do any transactions, we can take that exchange that we did and we'll go back to the blockchain and take our original Bitcoin. I don't know if you see what I mean.
No. You lost me on one part.
Yeah.
So what I want to know is how is the consensus
Yeah.
done?
That's what I'm building.
And
That's what I'm building up.
okay,
Yeah.
okay.
So it
okay.
uses multi-signature patterns and
Okay.
time locks. So we can decide to open a channel for 1 month, right, or 1 day. So when we check in money into that account, each of us will have to pay each other back the amount that they're checking in, so that if the time expires, we can take that check back to the blockchain and we'll get the original amount, right? So now you see now that a Lightning transaction is just us updating that amount that we'll take back. So if now I say, okay, we had 1 Bitcoin, it means at the start you will put 1 Bitcoin and I'll write a transaction that returns you 1 Bitcoin. You write a transaction that returns me 1 Bitcoin. So if the time lock expires and we take that back to the blockchain, we would have our Bitcoin back, right? But if now I pay you 0.5 Bitcoin, I'll update the transaction now that says, okay, I have 0.5, you have 1.5, and we'll accept that. That's our consensus. So when we go now back to the blockchain, I will go back with 0.5, you will go with 1.5. So it's like that stack, that original one that gave us 1 has been overridden by the new one.
So not all the transactions are updated on the main blockchain. It's only the last one, because the last one will give you the final, let's say the final account balance. Let's just call it like that.
Exactly.
And that gets now updated on the main blockchain. So and then can you delete that channel? So does that mean you can actually delete that channel and you lose track of all the transactions?
You can't.
Or the Bitcoin will only keep you can't.
Because if you delete it, you are closing the channel. So we'll go settle it now on the blockchain, right?
So when you settle it, but just it doesn't settle with all the transactions. It only
No, it
settles with
settles
the
only with the
final
last
transaction.
one. Yeah, that's why
Yeah.
the when you construct the channel, the first thing we
Mm-hmm.
do is that whatever amount I brought in, you pay
Yeah.
me back that amount. So that if we close that channel, we go back with our original amounts because
Original amount.
it's a multi-sig. Two of us have to do is an and.
Uh,
This and A
yeah.
and B have to agree. That's a consensus on the balance.
So, yeah. And then, but that's a 1-to-1 channel, yeah? 1-1
Yes,
channel.
1-1, yeah.
Now, so can you have end-to-end channels, or is there a
No,
limited number?
not quite, because
Okay.
like we said, you create a graph from those. So I have a channel with
Yeah,
you,
I
you
see
have a
now.
channel with Bobby. Now, if I want to pay Bobby, it will just
So
find a route.
yeah, okay.
Yeah,
Yeah, I see now. Yeah, I see. So you just follow the graph, and if you're
yeah,
on this node and this node already has a connection with that one, then
yeah.
okay, I see now. So we keep hopping.
Yes.
Okay, cool.
But
Yeah.
you can have different channels with different people.
Different
So
people, yeah.
you can have a
Yeah.
channel with Bobby, have a channel with me, have a channel with SLA, have a channel with the boss. But these are
Yeah.
different channels.
Oh, the boss.
Yeah,
You just put that name in my head. The
yeah.
boss.
So these are different channels. So that's
Yeah.
that. And you see that you now, if just like you see how, because networks like Ethereum, they came up saying they want to, Bitcoin does not scale. They want to make things faster, but they ended up Ethereum now,
Complicating
yeah,
things.
complicating things, and then people are
Yeah.
paying hundreds
I
of
feel that
dollars.
too.
Yeah, 1 minute. Yeah, yeah,
The man that they
DJ,
enjoy.
yeah. So the men, like the term guys, right? The term
Yeah.
guys said that they're here to fix Bitcoin, right? And then when I created a
Mm.
system that you can want to send $10, so you end up paying $8 in transaction fees, if not
Yeah.
$12. Sometimes you pay more than what you even want to send because it's too like choked up. Like there's a lot of like traffic congestion.
I wrote my first smart contract. I think it was last week.
What
It
did you
was
do?
just a but I have this friend of mine who's doing a master's in blockchain, yeah. And because he has no, I mean, he has no background in software and computer
Yeah.
science. So we did it together. Actually, he had one tutorial, and the tutorial was about setting up the environment to write your smart contract. So you had to install things like MetaMask. I
Yeah.
think.
Yeah,
I
yeah,
don't know if you know
MetaMask.
about
Yeah, I know
MetaMask.
MetaMask.
Yeah,
Yeah.
yeah, which is
I
basically
use it.
your local blockchain. Yeah,
Yeah, I use it
yeah,
actually. Yeah.
yeah. Yeah, installed a bunch of things. It was done with Truffle. Yeah, Truffle and Node.js.
Okay. All right.
So yeah, and then so I took his tutorial and I started. Oh, it just disappeared. So I took his
I'm here. I'm
tutorial and
here.
I started going through it. So editorial was basically just writing
Yeah.
your own smart contract, and then the next part of the tutorial was just about creating your own token
Yeah.
and all these things. So yeah, it was interesting to do that. I've never written a smart contract before.
It's very
So that was
simple actually.
so,
Yeah.
so it was sweet, you know the feeling that you get when you discover new technology,
Yeah.
and then you read it and you go through it and then you understand it and you're like, oh wow, this is actually interesting.
It is.
That was really cool.
It is. You
That
can
was
do
really
all
cool.
sorts of things like ticketing systems and the rest,
Yeah.
where you could say, let's say each an account in your smart contract, you start by saying you have 30 tickets, and then you write now a contract
Yeah.
that,
You can
yes,
specify the maximum, and
yeah,
then you
right.
can
Then right
yeah
now a
and
function to update it. So when somebody comes to your site
yeah.
and they buy, you when you issue the ticket, you go to the blockchain. It could be now some hash. You go to the blockchain now and reduce the number.
And
And
reduce the number,
yeah,
yeah.
yeah. So
And then you broadcast it. You can also broadcast it to
yes,
everyone.
yes. So
Yeah,
that's
yeah,
how
yeah,
they'll
yeah.
verify. So when they come
Yeah.
now to your club, right, and they show their ticket on their phone, you could put it as a QR code. So when they
Yeah.
scan, you make sure that that ticket was registered. So that's
Yeah.
how you do it. It's that simple, yeah. Even for votes, like you could use it for votes. You could put many things. So you could tokenize almost anything. Like take a house, and like tokenize it like as a small data structure, right? Put it on the
Yeah.
blockchain, and then as people
So
pay rents, you now
yeah,
deduct.
they're basically supercharged objects, man. Supercharged objects.
Yeah,
Object with logic baked into it. To
yeah,
me, it's like when we do, for example, object-oriented programming. So you take that object and you implement some rules inside, but the key rules are that everyone will be informed of whatever changes or whatever
yeah.
mutation that you do with that object.
The
It's
interface, yeah,
really, really cool. Yeah,
yeah,
yeah, yeah, yeah.
yeah.
So that was really cool. So I did that, and now I'm a lot more interested in blockchain.
It is DJ. Like I for one, I'm mostly like a Bitcoin person because like I've gone through the route of Ethereum, Cosmos, Polkadot, but when you look at it, those ones have foundations. See, like Stellar, they have a foundation. That means it's not different from the government as we know today. They can wake up and change the rules. Like Ethereum was first of all a proof of work network. They changed it to they're still almost 6 years in the making. They keep promising. So and they keep changing. You can never know the max supply. So that means I can't store my wealth there because one thing about money is that it should be scarce and yeah, it should be divisible and things like that. So
They can
Bitcoin,
abuse Ethereum.
yeah, so exactly.
They can still
So
abuse it. Yeah.
yes, and then if you
I.
look at it, the proof of stake also can be abused because rich people now can just buy more and stake, and then they have a position.
Yeah.
Bitcoin,
Yeah.
you cannot add money into Bitcoin without you developing the network, because if you want to add like 10 billion into Bitcoin in terms of stake, either you buy mining machines and then the demand for miners will go up and then that will drive innovation, right? And then you come and compete. So when you compete now, if you beat everybody, the network will adjust. Right? The network will be more difficult. So there will be a time that you will not be able to mine with this super computer you have. Like when Bitcoin started, they were mining with regular laptops. Right, that's how the first people started, and over time they went now and discovered ASICs. Them because Bitcoin does not use a CPU because CPUs do logic, right? If this do
Yeah.
that, but hashing is just one thing. It just hashes. So they now created machines that do only one thing. They just hash. That's all they do. So before they were using GPUs because GPUs the graphic processors are faster.
Yeah.
They are there to
Well, they
manipulate
are good with
numbers.
big numbers.
Yes, exactly. So they were
Yeah.
using
Matrices
GPUs,
and stuff.
and then people were competing, and then competition. Some people came and said, "What? I will show you what it is to hash." The way they created
Yeah.
ASICs. So ASICs is only hashes, give you like a tera hashes a second. So and then the total hash power of the Bitcoin network, like 4 or 5 years ago, it was 1,000 times faster than the world's supercomputer. That's if you take the hash power of the entire network that is securing the Bitcoin network, is 1,000 times and more powerful than the world supercomputer. Yeah, but you can't guarantee that in like a proof of stake system.
Yeah. Well, someone can just buy a bunch of Ethereum and then they
Yeah,
they now have the responsibility of
yeah. There's no proof
resolving
of
all the
work. Yeah,
transactions.
there's no proof of work. So the thing is that with money loses its value when you can make it out of nothing. Or the less you spend to make money, the less valuable it is because you can make more. And that's why gold used to be layer one for money before they took it off and made paper itself. And it doesn't cost much to print paper. So governments can just print more money and print more money, and then our purchasing power is dwindling, it's going down. So, but
That's what they're doing now.
yeah, with proof of work, you have to work. Proof of work now guarantees the conversion because energy cannot be created or destroyed, but it can be transformed, right? Law of conservation of energy.
Yeah.
So now, and then the thing too is that fundamentally, one problem Bitcoin solves is that it gives you digital scarcity, right? Like, if you have a movie you can copy it, or a picture, you can copy it an infinite number of times, right? Like I can copy, if I copy this acorn paper, everyone in my village can copy it. So, and that's the fate of computers. We do not have scarcity. We cannot create something that is scarce, because so long as people have access, they can download it or copy it an
They can
infinite
always
number of
make a
times.
copy, a digital copy of
Yeah.
it. Yeah.
So that means we didn't have any native scarce as the Bitcoin is the first scarce asset that is native. Because, and what guarantees that is proof of work, because once they have expended that energy to get that nonce, right? There is no way you
Mm-hmm.
can redo that. As that transaction is added to the blockchain and they're signed, only those that
Yeah.
have the authenticity can use it, right? But
Mm-hmm.
it's append only. So as you're adding other blocks on top of a block, that one that is buried down becomes stronger. So it's like building a fence where if you have a block, you add another block, the block under is more secured by the ones on top of it. So as you're adding different blocks on top, it's becoming
Yeah.
more and more valid. You see? Yeah.
Now that you spoke about digital assets and digital media,
Yeah.
and what do you think about NFTs then?
I don't see the value, because
Mm-hmm.
uh, Ethereum is like that. Ethereum is fond of bringing changing narratives. So every time they innovate, they bring a new thing that they can use blockchain to solve. The blockchains are meant to solve. The main thing for blockchain to solve is money. Something that all of us want to know, have consensus at the given time, that we know that it needs to be scarce, and all of us need to agree on it. Things like
Mm-hmm.
money. So when you say NFT, I could. What is the guarantee that me who sells you the NFT, I will not sell it to another person? That
Well, it's on the blockchain.
so so what?
It's on the blockchain unless you copy that and create a different token from it and then
I own
sell
it.
it again.
I own it, right? I paint a
Yeah.
picture. Let's say I have this picture here. I put it
Mm-hmm.
on Ethereum. As an NFT, I sell it. What's stopping me from going to another NFT platform and then I go and put it there and sell it again?
Yeah.
So fundamentally, philosophically, I don't see anything backing it.
Mm-hmm.
Yeah, if it's that, see, like, if it's a blockchain that is producing it, that we know that outside of that, there's no way to produce it, then fine. We could make it non fungible. We could make it in a way that there's only one copy, scarce. Just like how new Bitcoin does not come from outside, it comes from the Bitcoin network.
From the system. Yeah.
Yes. So that way you can make sure that it's scarce, because it's not coming from outside. But for NFTs, it's the artist that produces it. So he does not live inside of a blockchain. If he was living inside of a blockchain. So when you're used to the crypto space, you start seeing some small things like this that will just show you that, man, these people are just riding this wave and they will just make money and then to die. There's so
They
many
would
things,
die, yeah.
yeah. Even if it doesn't
That's
die,
what
there's no
happens.
real value in it, because it does not solve any problem that like really needs to be solved.
Well, someone can say that about Acon coin, yeah. Someone
Yes,
can say that about it as well and say it's
yes,
just riding the wave of cryptocurrency.
yes.
Um, but what do you think about it?
So the thing is that money is also it's a shelling point. A shelling point is just, again, consensus, what most people will agree on. So if
Mm-hmm.
we agree that a coin has value, then it will have value, right? Like if
Mm.
we only use US dollars because we know that it has value and we believe it
Yeah.
will have value in future. That's why we own it. So with money, that's what gives money value. So for a coin, right? If the more people believe that it will have value, the more they'll buy and keep, and then you use it to sell and buy, right? So
Mm-hmm.
now that will give it value, right? So that's what I think about it. It's just like different currencies, right? So if it doesn't have
Yeah.
value, then we would see that. But things like this NFTs and all other things that come in fashion and then go away, they are different.
Um, but there's one fundamental, well, not fundamental, but there's one thing that NFT brought in my mind,
Yeah.
which is really digital arts.
Yeah.
Because we can argue that if I'm an artist and I paint something,
Yeah.
and I put it in the system, I can always take the same thing that I painted and put in another system, in another exchange, or another platform. That's true. But there's, especially with AR, so augmented reality, virtual reality, and all these things, I think digital media and digital arts have a great opportunity to be put on the blockchain, because you will now be able to buy these digital assets, and you can own them. Think about an avatar that you can put on the in an augmented reality world, for example.
Yeah.
So you can buy that avatar, and to make sure that it belongs to you, you have that transaction in the blockchain. Now, it doesn't stop someone from creating an avatar that looks exactly like yours. But the reality is that digitally, the avatar that you have belongs to you, and only you and only you.
Yeah, that I
So,
mean that's fine. If the consensus now, that's fine.
Yeah, think about Pokemon stuff, Pokemon characters and everything.
Yeah.
So that means you can go and buy a character, and it belongs to you now, and it's on the blockchain, so no one can change that.
Yeah. And
So
the point is
that's
that,
how I see.
yes, but the point
digital,
is that the point is that blockchains are actually very inefficient, in the sense that they, with the consensus, like if you have a decentralized network, syncing them up so they come to consensus.
Yeah, I
Blockchains
see where you're going.
You can use a regular SQL database that would do that
Yeah,
thing. You don't need to come and put it. You don't need to come and put it on top of a blockchain. So that's why I'm saying that people are just excited. People are just excited.
Yeah, that's what I'm saying. I see exactly where you're going. So that's why I started laughing, because I was like, this guy is just gonna be like, why don't you just put it on the regular DB? and you can implement a unique ID, and a unique ID does the same thing.
Exactly. So now you come and put on the blockchain, so that investors will be like, oh, this new crypto space, Bitcoin has like 900 or something $billion worth of that. So investors, angel investors, pumping money, and then they go and make the thing, and then after that, the early people make money. Yeah, and yeah,
it's a buzzword. Now.
Yeah,
it's really,
exactly.
Really so people take advantage of that.
Yeah.
I have to go soon, man.
Yeah, DJ.
But,
I mean, we're spoken
next,
for like 57 minutes. This was great, actually.
We need to speak about Acoin. So I'll go and read the white paper of Acoin first, and then we'll need to speak about it next time.
Okay, that works. Yeah.
Yeah.
Mashallah.
I need to go. See you, man.
Yeah, DJ. All right. Thanks for your time. Yeah, see you. Yeah. So everyone, thanks. That was a nice chat with the DJ. We went through like some technical concepts, and we'll proceed with that. If you are not used to the crypto space, try to check it out, because it's a space that gives us sovereignty. So it gives you the ability to manage your own assets, as opposed to like having middlemen like banks and the rest giving you a savings account. You will not be able to like accrue value, because as our currencies are more printed, we have inflation, right? So your purchasing power is going down. But with these networks that are decentralized, like Bitcoin, there's no one to print more, so you're guaranteed. And then there is a maximum supply, so you're guaranteed that at a certain point the demand will exceed supply, and that's the core of scarcity. So if you're interested, check out the crypto space. You'll not regret it. In like 10 years or so, you'll be able to create your own wealth and generational wealth. Thanks, guys. Peace.